Hello guys, how are you today? So today I'll be explaining the math course practice quiz of 4.3 IGCSE. So let's start with the first one. A particle moves in a straight line so that its displacement s in meters from the fixed point O after t seconds is given by s is equal to t3 plus 3t squared plus 6t. When is the particle at rest? And what we should know is that a particle is only at rest when its velocity is equal to 0. Now, how do we find the velocity if we are given its displacement? Very simply, you should know that displacement, if you take its derivative, it's gonna give you velocity. And velocity, if you take its derivative, it's gonna give you acceleration. Please keep this in mind, it's very important. So we have the equation of the displacement, which is t to the power of 3 plus 3t squared plus 6t. Okay, so we are gonna take its derivative. We are gonna derive it and we will get its velocity. So if we take its derivative, okay, we are gonna get 3t to the power of 2 plus 6t plus 6. Now, for the people who have the calculator that has the function mod 5, 3, please do put it on the calculator. So you're going to click on mode setup, then 5, then 3. For A, you're going to put 3. For B, you're going to put 6. And for C, you're going to put 6. And you are going to get what? Two numbers, which is minus 1 plus I, minus 1 minus I. Whenever you see I, it means it's an imaginary or impossible number, so that means it's never happening. So instead of I, you just know that it is never or impossible. Okay, now for the people that do not have the mode setup thing, we can very simply find the discriminant. So if we find the discriminant, we know its equation is b squared minus 4ac. So our b in this case is 6. It's gonna be 6 squared minus 4 times 3 times 6. So if you put it on your calculator, 6 squared minus 4 times 3 times 6, you will get a negative number, which is negative 36. Now, whenever we have a negative number, that means it has no real roots. And if it has no real roots, that means it is impossible or imaginary or I. And we said, again, if it's impossible or imaginary, it means never. So what we can say about this particle is that it is never at rest. So we move on to the next thing. Okay, so for question number 2, a particle is moving along the x-axis so that any time t seconds, its position from the origin O is given in meters by xt is equal to 2 squared plus 8t minus 5. The average acceleration of this particle between time is equal to 3 seconds and time is equal to 5 seconds is a meter per second squared. Now, what is the value of a? Enter only a number for your answer. So very simply, there are two ways to do this. The first way is to, as you know, that the displacement gives as a derivative velocity, and velocity as a derivative will give acceleration. So we can keep on doing the derivative. So if we take 2t squared plus 8t minus 5, and pay attention, this is the displacement. You take its derivative, it becomes 4t plus 8, and you do the derivative again, you're gonna get 4. So 4 is directly your answer, which is acceleration. It's the acceleration of anything between any two numbers. Or a second way is to take the velocity, okay? So you take velocity v, you take this equation over here. So to find the velocity, we're just gonna take this equation. And they said the particle between time 3 seconds and 5 seconds. So very simply, we'll find, first of all, the time at 3 seconds, or sorry, not the time. We're gonna find the velocity at 3 seconds. What is it? It is gonna be 4 times 3 plus 8, which if you do it on the calculator, you will get 20. And then the velocity of 5 seconds, if you do it on the calculator, it is 4 times 5 plus 8, which is gonna give you 28. Now what we're gonna do is we're gonna do velocity minus velocity over time minus time. So let's say velocity 320 minus 28 over the time, which is 3 minus 5. If you did it on the calculator, you will get an answer of 4. And no matter which 2 seconds you chose, if you chose 501, you did it, you put it on the calculator, you are still gonna get 4. So the first way is to directly find the derivative, or the second way is to find the velocity rule. So in all cases, the answer is gonna be 4. We move on to question number 3. A traveler left home at 7:30, drove for a while, and then returned home. The diagram below describes the trip. They said the average speed during the time interval of 8:30 to 9 is y kilometers per hour. So what you're gonna do is they need us to find the average speed. So to find the average speed, first thing we're gonna do is take the 2 time intervals, which is from 8:30 all the way until 9. Cannot see properly. So from 8:30 all the way until 9. Next thing we're gonna do is we're gonna take their corresponding distances. So we have here 180 and 120. Now what we're gonna do is we're gonna do y minus y over x minus x. So it's gonna be 180 minus 120, but here we have a small issue. From 9 till 8:30, there is a difference of 30 minutes, but do they need it in minutes? No, they need it in hours. So what we're gonna do is we're gonna change the minutes into hours. So it's gonna be 30 divided by 60, which is gonna be 0.5 hours. So divided by 0.5 hours. If you put it on the calculator, you are gonna get an answer of 120. So the average speed of the time interval this to this is 120 kilometers per hour. We move on to the next question, which is question number 4. Okay, a particle is moving along the x-axis so that at time t its displacement from the origin is x meters, where xt is equal to 8t squared minus 5t plus 13. Its velocity when t is equal to 2 seconds is p meter per second, where p is a whole number to be determined. What is the value of p? Very simply, we have what? We have, this is the displacement, okay? And they need us to find the velocity when the time is 2 seconds. So we know that the velocity is a derivative of the displacement. So we're going to take the equation of displacement, 8t squared minus 5t plus 13, and we're going to find its derivative. It's going to be 16t minus 5. Okay, now this is the equation of what? Of the velocity. So what we're going to do now is we're going to find the velocity when the time was 2 seconds. So very simply substitute the t by 2. Make it equal. So 16 times 2 minus 5 will give you an answer of 27. So our answer is then 27. We move on to the next question, which is question number 5. A particle moving along the x-axis so that at time t seconds, its displacement from the origin is x meters, where xt minus 1 over 3t squared plus 4t minus 4. Okay, the average acceleration during the first 2 seconds is a meter per second squared, where a is a whole number to be determined. What is the value of a? Now, first thing we know is that this is our displacement, and to get the acceleration from displacement, we first have to find the velocity by doing derivative, and then by doing derivative again, we find the acceleration. So again, let us do it. It is then gonna be 1 over 3t to the power of 3 plus 4t minus 4. You find it's this the derivative, it's gonna be t to the power of 2 plus 4. You find it again, it's then gonna become 2t. So this over here is the equation of the acceleration. Now, they want us to find what? The acceleration during the first 2 seconds. So second 1 and second 2. Okay? So you're gonna take it as 2 times 1. Okay? Which is gonna give you 2. This is acceleration 1. And then acceleration 2, it's gonna be 2 times 2, which is 4. And then again, we're gonna do acceleration minus acceleration over time minus time. So let's say we did 4 minus 2 over 2 minus 1. If you put it on the calculator, you are gonna get an answer of 2. So the value of A, which is the average acceleration, is gonna be 2. We move on to question number 6. A particle moves in a straight line so that its displacement s in meters from the fixed point O after t seconds is given by s is equal to t to the power of 3 minus 5t squared plus 20t plus 1, where t is between 0. They told us they need the distance the particle travels during the third second. Now here they're asking us for what? They are asking us for the distance, the velocity, or acceleration. For the distance. And they give us the equation of what? Of displacement. So displacement, distance, same thing, okay? So we're not gonna change the equation at all. So the equation we will be using is t to the power of 3 minus 5t squared plus 20t plus 1. So they said they need the distance travels during the third second. Now, when we take third second by itself, we're gonna take the total distance it has traveled. So is this what we need, or we need the distance it traveled during the third second? No, so let me explain it again. Let us say it starts here, initial point, and here this is final point. And let's say it has a total distance of, let's say, 100 meters. First second here, second second here, third second here, and fourth second here, fifth second here, whatever. All right, so in the third second, if we use this equation and we put 3 seconds, we're gonna get the total distance traveled. But them, they don't want this total distance. They want this distance over here. So we're not only gonna take 3, we're also gonna take 2, and we're gonna subtract them. That's pretty much it. So for 3, it's gonna be 3 to the power of 3 minus 5 times 3 squared plus 20 times 3 plus 1, and we are gonna get 43. For 2, if you put it on the calculator, you are gonna get an answer of 29. So now you are gonna subtract them, and you're gonna get 43 minus 29. You put it on the calculator and you get an answer of 14 meters. So pay attention by the wording. They need travels during the third second, not the total distance traveled. No, the distance traveled during the third second. So from between 2 and 3. So the answer over here is gonna be 14. We move on to the next question, which is question number 7. A particle moves in a straight line so that its displacement s in meters from the fixed point O after t seconds is given by s t to the power of 3 minus 5t squared plus 20t plus 1. The time when the acceleration is 14 meters per second squared is... Okay, now this is just a reverse equation. We are given what here? We are given the displacement, and we know to find the acceleration from the displacement, we need to find velocity first. Then we need to do derivative again to get the acceleration. So t3 minus 5t squared plus 20t plus 1, you're gonna get 3t squared minus 10t plus 20. Do derivative again. You are then gonna get 6t minus 10. So 6t minus 10. Now we know it is equal to what? It's equal to this acceleration, which is 14. Okay, now we're gonna solve it again. So 6t minus 10 is equal to 14. Move it to the other side. 6t is equal to 24. So the time is equal to 4 seconds. And that's it. We finished. The answer over here is 4 seconds. We move on to question number 8. Here we have a graph, and they asked us for the average speed of the train between 9:30 and 11:30. So we're gonna go 9:30, 11:30. Here we have 300 kilometers, 150 kilometers. So you're gonna do y minus y over x minus x. So here this is a difference of 150 kilometers. Here it's a difference of how much? Of 2 hours, okay? So they need it in kilometer per hour, so it's gonna be 150 divided by 2 hours. 150 kilometer divided by 2 hours will give you an answer of 75. We move on to the next one. Here there is also a distance of 150 because they said from 7 to 9:30. So also a difference of 150, whereas here it's a difference of 2 hours. And, sorry, not this. Talking about here. Here it's a difference of 2 hours and 30 minutes. So we cannot deal with any minutes. We need to change it to hours. So 30 divided by 60, this gives an answer of 0.5 hours. So 2 plus 0.5 is 2.5. So it's going to be 150 divided by 0.5. It's not 0.5, sorry, 2.5 hours. And we will get an answer of 60 kilometers per hour. We move on to question number 9. So here it's important to read why. A train started from rest at 7, etc., etc. What you need to get is what? The distance traveled during the entire hour, which is 63 kilometers. This is gonna help you find what? It's gonna help you find the height, which is the velocity. So they want us to find the maximum speed, and the maximum speed here, it's the velocity. So in this case, to find it, you're gonna do that the area of the graph in this case is equal to the distance, and our distance is 63. Oops. So 63 is equal to the area of the graph, which is a trapezoid. It is the height, which is v, times base 1. Base 1 is a total distance of 45 minutes. If you change 45 minutes into hours, it's 45 divided by 60, which is 0.75. And then the bigger base, it is 1 hour. So 1 hour plus 0.75 hour is 1.75, okay, over 2. So multiply by 2, 63 times 2 is 126. 126 is equal to v times 1.75. Divide both sides by 1.75. You are gonna get that our answer v is equal to 72 kilometers per hour. Now they need the average acceleration. Very simply, to find the average acceleration during the first 5 minutes, you're gonna take the velocity v, which is in this case 72, minus the final velocity, which is 0, or you can do it opposite, final minus initial, initial minus final, whatever, over the time difference. The time difference is 5 minutes, but you need to change 5 minutes into hours. To change from 5 minutes into hours, you are gonna divide by 60. So you are gonna then get 72 over 5 over 60 if you put it on your calculator. Please do not forget to put the brackets. So when you put the brackets, it's gonna be like this. You are gonna get an answer of 864. So very simply, 864 kilometer per hour squared. So let's submit, and hopefully there are no mistakes. Thank God there are no mistakes. Thank you guys for watching. I hope you enjoyed, and have a wonderful day.